Okay, so in this question, it tells you that you've got a bag containing 3 red marbles and 4 blue marbles. And it tells you that they are taken at random and that they are replaced. And the key part of this question is that they are replaced. And it wants you to work out the probability that the 2 marbles taken from the bag are the same colour. There are different ways of completing this, but the easiest way for you to visualise it and complete it is to draw a tree diagram. So we have a red and a blue. We know that there is 3 red out of a total of 7 marbles and 4 blue out of a total of 7 marbles. Because these have been replaced, we know that the probabilities will stay exactly the same. So we just repeat it: 3/7, 4/7, 3/7, 4/7. Now that we've drawn our tree diagram, we can use it to work out our probability. So it wants to know if they're the same colour. There are 2 different ways of doing this, and that is getting either a red and a red or a blue and a blue. We can work out these probabilities by multiplying them together. So 3/7 times 3/7 is 9/49, and 4/7 times 4/7 is 16/49. You have 2 different ways of achieving the same goal, so therefore we need to add these together to get our final answer, and that is equal to 25/49. I want you to give your answer as a fraction, so leave it in this format. Okay, our second question tells you that Sheila either walks or cycles to school. The probability that she walks to school is 0.65, and then it tells you about the probabilities if she is late. So again, we're going to draw a tree diagram, as it's the easiest way to visualise what's going on and to get all our information recorded down. So we know she either walks or cycles. If she walks, her probability is 0.65. Therefore, if she cycles, it must be 1 take away that probability of walking, which would give you 0.35. If she walks, she can be late or on time. So if she walks, the probability that she's late is 0.4. Therefore, her probability of being on time must be 0.6, because we know probability is up to 1. And again, if we do it for our cycle, probability she is late is 0.1. Therefore, on time 0.9. It wants you to work out the probability that on any one day she will not be late for school. So we know she could walk and not be late, so arrive on time, or she could cycle and arrive on time as well. So we then need to multiply our probabilities together. If she walks and is on time, it would be 0.65 times by 0.6, and that is equal to 0.39. And if she cycles and is on time, her probability would be 0.35 times by 0.9, which is equal to 0.315. We can now combine those 2 probabilities to get our answer. So 0.39 plus 0.315, and you get 0.705, and that is your final answer. In our next question, it tells you that we've got a bag with 11 counters, 5 are white, therefore 6 must be not white, and then it tells you that they are not replaced. Again, highlight that key word, because that means our probabilities are going to change. So we have white and not white, 5 out of 11 and 6 out of 11. If we picked a white to begin with, that means there's 1 less white in the bag because it hasn't been replaced, and 1 less in total. And our non-white stay exactly the same. If we picked a non-white to begin with, our amount of whites don't change, but our non-whites have decreased by 1. It wants to know the probability that one counter is white. That means we would get a white and a non-white, or a non-white and a white. There are 2 different ways to get only one white. We remember to multiply to get 30 over 110, and 6/11 times 5/10 is 30 over 110. We've got 2 different ways of achieving the same goal, so we add together our probabilities and we would get 60 over 110, or 6 over 11 if you simplified. Remember to read the question, it wants you to keep it as a fraction. Our 4th question, we've got the probability of Aaron going to the gym versus not going. It tells you his probability of going is 0.8, therefore the probability of him not going must be 0.2. So it tells you if Aaron goes to the gym on Saturday, that means we're looking at this tree diagram here, the probability that he goes on Sunday would be 0.3. So therefore the probability doesn't go is 0.7. However, if he doesn't go on Saturday, that tells you the probability he will go on Sunday is 0.9, therefore the probability he won't go is 0.1. I want you to calculate the probability that he goes on exactly one of the 2 days. Again, that means he would go to the gym on Saturday and not go on Sunday, or he could not go on Saturday and go on Sunday. We remember that we multiply to go from tree to tree, so then that becomes 0.8 times 0.7, and that is equal to 0.56, or 0.2 times 0.9, which is equal to 0.18. We've got 2 different ways of achieving the same goal, so therefore we would need to add our probabilities together and we'd get our final answer of 0.74. Our final question tells you that there's a box which contains 10 pins, 3 are blue, 7 are green. 2 of the pins are taken without replacement. So again we're going to draw a tree diagram. We've got blue, we've got green. 3/10 are blue, 7/10 are green. So then on our second pick we could pick a blue or a green, or blue or a green. If we picked a blue to begin with, so we're looking at this tree diagram here, there would only be 2 blues left and 1 less in total, and the amount of greens wouldn't change. If we picked a green to begin with, the amount of blues wouldn't change, however there's 1 less in the bag, and the amount of greens would be 1 less. Again, just like in all the questions so far, you can check that your probabilities add to 1 on each tree. They do in each tree, so therefore we can continue. It wants you to work out the probability that they are the same colour. That means we could pick a blue and a blue, or we could pick a green and a green. There's 2 different ways of achieving that goal. So now we need to multiply our probabilities together. 3/10 times 2/9 is 6/90. 7/10 times 6/9 is equal to 42/90. 2 different ways of achieving the same goal, so we add together our probabilities and we would get 48 over 90 as our final answer.